Okay, so in this video, we're going to take an introductory look at this concept of data structures. So in one of my previous videos, we talked about this idea of an abstract data type. And we said that an abstract data type was simply a type defined in terms of its data and its associated operations, but it didn't say anything about the actual implementation. So this is where we're getting into the idea of a data structure, when we talk about the implementation of an abstract data type using specific structures. Another way that we could talk about data structures is a specific way of storing and retrieving data. And we want to be able to store and retrieve data in a very efficient way. And so associated with any data structure we have, and really the only ones we've talked about in any great detail, is the array and the vector in some of my previous videos. So certain structures lend themselves to being better at some operations and not being so great at other operations. So in terms of selecting the appropriate data structure, you really have to figure out what sort of operations that you're going to be doing and how often that you're going to be doing those operations. So let's go back and talk a little bit about this reservation system that I brought up in the abstract data type video. So we said we wanted to be able to model this idea of a reservation system for maybe a concert hall. And in terms of an abstract data type, we would think about what the data items were and what the operations were. So for the data, we said that we would need to be able to model the seats, represent the seats, and we would need to be able to have the seats maybe being represented as being reserved or available. And the other thing is, dealing with the operations, is we would need to have the operation of being able to determine the available seats, to be able to reserve a seat, to cancel a reservation, maybe find a block of available seats. So there's lots of different operations that you could imagine. But we haven't said anything again about the actual implementation. So how would we go about implementing or having a specific representation, a specific structure for the seats? And that's what we're going to take a look at next. So in terms of implementing or representing these seats, one thing that we could do is go and declare in-character variables for in seats. So we may have 300 seats in a concert hall, 500 seats. I don't know what the typical number is for a concert hall. I guess it depends on the size of the concert hall. But whatever it is, we could declare that number of character variables for the number of seats. And that has certain implications in terms of how efficient things can be done. So if we were using character variables, we'd have to go in and declare however many character variables that there would need to be. And all those variables would initially probably be marked with some character to represent that they were available. So maybe we mark them with the character A. And then when we go in and reserve a specific seat, we could mark that particular character variable with an R to indicate it's reserved. And then we'd have to think about, well, what about the operations? How do we go about listing maybe available seats? So that could be, quite troublesome with just having a bunch of variables being declared. So we can imagine maybe having, S1, S2, all the way through Sn representing our names for our character variables, and each one of those variables would have a value associated with it, A or R, indicating whether it's available or reserved. Now, if we wanted to be able to list out all the available seats, we would have to go in and code up and specify or do a test on every single variable, testing to see if that variable S1 is equal to A. If it is, we could output that to the user. If S2 was equal to A, we could output that to the user. So you could see how tedious this would be in the way that we've structured this data just by using variables. Now another thing that we could do is use a character array as opposed to using character variables. So we could go in and create a character array of a specific size, and in that case we would have something very similar. We would still want to go in and maybe mark all of our elements initially with A, and then if we reserve a specific seat, and then we could mark that element with an R. But again, we would have to deal with certain operations. So how do we go about listing available seats? Well, it turns out with an array it would be much more efficient and much less tedious on our part as a programmer to implement a traversal of an array. So we would just simply write a for loop, and that for loop would allow us to visit each individual element, and we could do a comparison between the contents of that particular element and a particular character. So if we were looking for available seats, we would just compare the elements contents to the character A. And we could do similar things if we were looking for the number of reserved seats or a block of seats or whatever it is. We could still do this idea of an array traversal. And the really cool thing about the array is even if we were to maybe apply this to a different concert hall, or this concert hall underwent renovations and added in seats or maybe reduced the number of seats, it wouldn't be much trouble to just pass in a new value for the size, assuming that we would have to pass in a value for the size. Again, this would be dependent on the language that you were using and what you were actually using within the language. But we could pass in, if we needed to, a new size for the array, whereas if we're dealing with a bunch of character variables, we'd have to go in and start declaring additional variables and marking those appropriately as well. Whereas, with the operations that we would be dealing with an array, it would be very easy for us to update the contents to fill out, additional elements with the same character. So we really wouldn't have to change much in terms of our code. And this is really one of the important things, in terms of software development, is actually using the correct or selecting the appropriate data structures. And we have to think about, what operations are required, what are the common operations, what is the efficiency of those operations. So again, we have to think about, are we going to be searching through this data a lot? Are we going to be inserting or removing data a lot? If it turns out that we do a lot of searching in comparison to doing very few insertions or very few removals, then that would make us select one data structure over another data structure. So it really is an idea of trade-offs and figuring out how you want to represent your data and how that data is going to be used. So that's pretty much it in terms of the stuff that I wanted to cover in this video. And just to sort of recap, a data structure is just a specific way to go about storing and retrieving data, and we want to have an ability to store and retrieve that data in an efficient manner. And so we have to go about selecting the right data structure. So we'll look at these data structures in turn in the upcoming videos. Again, we've already looked at the array and the vector, at least how they work, and we'll compare sort of the pros and cons associated with the array and the vector with the other data structures that we look at and compare those with each other as well. So that's it for this video.